Hello, everyone, and welcome to the second installment of our Securing the Stack webinar series, Turning Vulnerable Containers into Trusted Assets. And this is the series where we really focus in on everything container security. My name is Evan. I'm on our product marketing team here at ActiveState, and I will be your moderator for today's session. And today we really have another awesome session lined up to really dive a bit deeper into some of the techniques teams can leverage to really begin and start transforming their container images into trusted assets. Just a bit of really quick housekeeping before we get started. Just so everyone knows, this session will be recorded and sent out following the call, so there's no need to worry if you have to step away or you miss anything. We will make sure we get you those slides. And if you have any questions throughout today's session, please feel free to make use of Zoom's question functionality or the comments, and we will make sure to leave, hopefully 5 to 10 minutes at the end of today's session to get to those answered. So we got limited time, so I want to jump right into it. Without further ado, Mark and Morris, our guests today, would you like to both maybe take a quick second to just tell us what you do at ActiveState and your name, please?
Of course. I'll go first. My name is Maurice Chen. I'm the VP of Customer Success. I joined the company almost 2 years ago. I'm based in California, very close to San Francisco. It's a pleasure meeting everybody. Go ahead, Mark.
I'm Mark Goodman. I'm a development engineer, and I've been with ActiveState for 7 years, and primarily I'm working on creating the product. So working on hardened containers and creating distributions of all of the different languages we create, like Perl and Python and .NET, etc.
Awesome. Thank you both. It's great to have you here. I'm going to go ahead and stop sharing these slides. I think nobody wants to look at slides for an entire presentation, so we can see our awesome speakers here instead. So, I mean, Mark and Morris, you guys weren't here in the last session, but really, a couple of weeks ago, we started this series off and we really started to walk through, some common container security misconceptions, what are customers experiencing? What are people experiencing around container security, some of the challenge. And in that conversation, we started to introduce a few of the tactics teams can start to explore to, keep themselves secure. One of the things we sort of just brushed the surface on was these concepts of image minimization, image hardening. I think it'd be great to start the session off and just, maybe Morris, like, can you kind of bring that back up and explain, what image hardening and minimization actually are and some of the benefits they might provide?
Make sure I'm off of mute. Of course, that's a great question. It's a very common misconception. A lot of people use those terminologies a little bit wrong. It's really easy to explain them, and I'll go very quickly to kind of understand the differences between hardening and minimization. They serve similar purposes to make a container secure, but the clear definition is very specific to each one of them. So when we talk about a minimization is an act of or practice of reducing the container image to the absolute minimum of the components that need to be there to support an application on top of it. It's starting with a really clean base image. If you think about a very common base image could be Ubuntu, but Ubuntu will come with a lot of OS components in it. What we mostly recommend is to start with like a distroless environment that has really minimized all the attack surface options that are available there. We remove, or the ideal is to remove the unnecessary packages, files, tools, libraries, anything that is not absolutely essential to support the application. We include only the compiled applications, so none of the source code. So it's really just a very lean environment that has the bare minimum of what is required to support an application on top of it. The benefits of a minimal environment is to reduce an attack surface. It's a smaller image size. If you think about a container or an image, the idea is not to have a gig size image, is to really have something that has a very, very, very small footprint. Um, Even when you have a smaller footprint, then it's a lot easier to scan those files. It's a much smaller SBOM. So all the SA tools will go through that very quickly. And on the other side, the hardening or the image hardening is really to lock down the configuration of that container to be able to meet specific criterias or specific compliance requirements. So some of those things would be to remove, for example, the non-root users, drop in any necessary Linux capabilities that are not really required there, implementing our hardened SE Linux profiles. It's really to make sure that that environment is really locked down. There's applications like App Armor that you can put on it to really lock down the environment. You remove a lot of the binaries that might be vulnerable for attack or remote attack. Exploits, remove the shell, you move package managers. You're applying a lot of those options on the OS level patches as well. So it's really just making that level a lot harder to exploit. And the benefits of hardening versus minimalism or minimalist environment is defense in depth, compliance. When you talk about compliance specifically, NIST or PCI or any of those requirements, hardening becomes a mandatory implementation. It reduces the blast radius. So if someone does manage to hack a container, then there's no way for them to leverage that and to gain access to other components in the network. So it's really about securing that layer. And it has a very predictable behavior for that specific container. Hopefully that answered the question.
No, it definitely did. And I think, what we're really here to sort of dive into today is like, okay, it's great to sort of level set on what the benefits of this are, but, for teams or really, I guess, anyone on this call who wants to sort of start attempting this or kind of implement some of those practices you described, Morris, themselves. Maybe they've grabbed an image from Docker Hub or they've got their base image from somewhere else. Like Mark, you've been doing this work internally for us for a long time. Can you maybe help break down some of the work that's actually involved in doing this, or how you might approach starting, this work yourself?
Yeah, so the work is in a way straightforward because you're removing files and you're, setting permissions. But if you're pulling something that's already on Docker Hub, you don't necessarily know all the things that are on it. So you would need to kind of trace through and look. So it's definitely going to be easier to start with a minimal image and build up from there rather than start with, I if you have an application image on Docker Hub and you want to make it secure, because then you have to figure out what you can remove and figure out what doesn't have permissions, proper permission set. And, if you set the permissions, then your application might not work anymore. So definitely going to be easier to build up from a blank uh, from a blank container.
Yeah, and that's something I kind of wanted to, dive a bit further into, Mark, is like, how difficult is this work really? Like, if you want to start from this kind of fresh minimized container, you just talked about like, hey, if I change this thing, what's going to happen? Like, is there a point where you can maybe go too far? Let's say you minimize the image too much and now it's impacting the, effectiveness or the usability of the image itself. Can you kind of just talk about some of the difficulty in actually doing this?
Yeah, I think for anyone who's a developer who's used to going in and analyzing what your application is doing, once you enter into the hardened zone, you basically would need to have a development container and a minimal container because your minimal container might not have like ls, for example, to see what's going on inside. And your minimal container definitely shouldn't have, root access. Um, so if you're doing that kind of work, you potentially would need additional tools to even look into the container because the container won't have the required tooling to do like regular analysis anymore.
Right. That makes sense. So I think sort of the question that comes to mind for me is like, we're here talking about image hardening and minimization. And so clearly, this is an engineering challenge that a lot of teams are trying to solve right now. Morris, I think in your position working with our customers, you sort of see this every day. I think we've also seen the market sort of respond with a lot of different options to help, offload some of the complexity of actually doing this work in-house. if I, let's say I want to have like do what Mark said and start from a clean kind of foundation, and I'm going to a vendor to look to help me out with this. Like, what should I look for? Are all of these things equal? I see these things on that bill themselves as secure or hardened images. Like, what am I looking for as a consumer of this?
So that's a great question. There's obviously a checklist that one in this position should definitely take a look at and go through. But really, not all of them are the same. It's really important to understand what it is that you need to achieve in delivering secure containers, right? The vendor that would give you not a point in time solution. So if we break this down, a stack is a little bit more than just a container. And when you think about vendors that you want to implement to support those endeavors, it's important to understand that a base container is one level. What comes on top of it are the libraries of, let's say, a language, a specific language, could be a Python, a Node, Java. That will be the second layer. On top of it will come maybe the open source applications, Nginx, MariaDB, or RabbitMQ, whatever it is you want to you want to put on top of it. And then on top of it, you have your first party code. So it's really important to understand that it's a full stack of layers that you need to make sure that your vendor can support. And on top of it, it's important to remember that you don't want a point in time because even if you build something that is secure, the moment you've built it, you have to keep maintaining it. So
Right.
always scan it, always update or replace with a new container. So those elements are extremely important to understand that. And this is the big differentiator why it's not really advisable to do it in-house. You can do it in-house, but the amount of resources and the amount of hours that you will need to invest in just even maintaining that, it will take a very simple image environment. Let's say we have 100 containers, which is pretty standard for a medium-sized deployment. Maintaining 100 different containers requires a lot of time, and it's usually not just DevOps or IT, in some cases, engineering as well. And when you want to offload it or you want to give it to a vendor that can provide you with those security and secured layers, it's important to understand that it's a lifecycle coverage. It's a vulnerability management. It's not just patching, it's entire vulnerability management. You want to have some sort of an integration to your SCA tool, whether you're using Wiz, whether you're using Black Duck, whether you're using Snyk. All those tools are amazing, but at the end of the day, they'll give you a very nice dashboard of this is what you've got going on in your container, but you need someone to be able to remediate those. So always remember, the SCA tools will give you a point in time a very nice dashboard that tells you all the vulnerabilities you have, but you have to remediate them. And this is where the difficult part is. And you need a vendor that can help you get there very quickly and continuously with your environment and security needs.
I just want to tag on to what Morris was saying because we literally yesterday had some CVEs come through our maintenance pipeline, and so we updated those CVEs in the pipeline, we sent everything off, and our results came back, and now there are additional new CVEs. So it is just a never-ending cycle, and yeah, it is very ongoing.
And just to, again, add to what Mark said, if you think about it, nobody has a very static environment. Everybody's a very dynamic environment. No, we don't always have like one language and one version and one setup that you say, you know what, if I've patched one, I've patched all of them. Every production environment, every development environment will have multiple versions and multiple types of installations. And just maintaining that could be a very, very expensive ordeal.
Right, Morris, I want to go back to something you mentioned kind of early on in your answer, which was that, it's not never just a container. You need to, go and get the language libraries. Maybe you're looking for images for, entire applications. And I wanted to ask you, like, kind of in the same mental philosophy of like hardening and minimization, like how important is it to, you know, understand where your open source components actually come from? Like you can put them in and format them however you want, but how important is sort of understanding the origin of those components?
Well, that's a great question because you just defined the entire supply chain methodology. Um, it, it's extremely important because we've seen this with Node, with the recent Node packages that were published and they were vulnerable. it's extremely important to understand that the packages and the governance, where they're coming from, will impact your security. So let's say if I download a pip install, if I do any specific installation on my image, I really don't know who's the author. I really don't know if it came from a secure source. I don't know if it was built from source. I know that I got a package. Um, for us, understanding where the source code is coming from, understanding what we need to do to evaluate that, how to build it, and securing the entire supply chain is extremely important. We have customers that will never get or will never accept anything in their environment unless it's signed, unless the author and the build and the components are discoverable within the SBOM. So when they do introduce something to their environment, no matter what environment that is, whether that's development or production, they know the entire or every step of the way for those specific packages, and they can account for them specifically in the signature. So they know that we downloaded from source, for example, we build it, they know exactly which components we build, where all the sub dependencies came from, and they follow the same process. How we deliver that to the customer, so there is no way to attack the supply chain delivery. So they know that those components will always be safe as long as they come from a trusted vendor. Um, it's very easy to compromise the supply chain. I think just looking at the news recently, you'll see how easy that is. We another factor of it is trust and provenance. You need to know that the components come from a trusted source that has done all the necessary governance training, testing, validation, quarantine, and has those tools to be able to safely provide you with components and patched versions of them as well, which is another important thing.
So I kind of want to jump ahead and ask, like what happens if I fail to do this? Let's say I'm trying to, I'm ignoring doing any of this minimization or hardening work. I'm sort of using my default kind of bloated container images, or maybe I'm running, unverified components in my kind of end product. I'm not really sure the origin of them. Like, have there been any attacks or incidents of note that either of you can think of that, sort of highlight the dangers and, not kind of going down this path and trying to sort out your container security?
Of course, I can share a couple of examples, but I'm not going to share the company names, obviously. But a few companies have come to us and said we're using we have a very interesting, very complex deployment of X amount of containers. I'm not going to mention the code, but they were hacked. They had outdated code that was deployed in production that worked beautifully. Like the code was working fine, but the problem was that those specific vulnerabilities have been published and remediated for months, and they were not able to deploy them. It's not that they didn't want to deploy them, the cost of deploying those patched versions or new images was just so long, and it would cost them so many hours that it got delayed in the priorities. And that's the best news hackers can find or can know, that there are vulnerabilities that are aware that are out there that are open, and they can exploit them because they haven't been remediated. So those companies, when they came to us, they said like, what we need is basically a secure environment. This it wasn't the first party code. It was just the libraries that they were using were extremely vulnerable. And when we ran a scan, and then when they ran a scan, they saw how many vulnerable open CVEs they had. They just couldn't prioritize them correctly. And this is where a solution like ours come into play, where we are able to take that report, convert that into an SBOM, make sure that we can track all the components that we have in your environment, every open source component, and be able to say, we can take a look at it, we can patch those, we can rebuild them from source, and then we can give you a version that you can deploy in your production environment. And I always say deploy in a production environment, but I am a developer, so I always say deploy this into your testing environment, like any other CI/CD pipeline. Whatever you consume into your production, go through the pipeline, go through testing, go through staging, and then push it to production. Um, and that's what we recommend our customers to do. That entire SDLC lifecycle or SSDLC lifecycle, which is a secure software development lifecycle. Make sure that it plays a very integral role into your CI/CD consumption of new images. So they go through the same testing, the same validation, the same deployment, and then, and only then, you deploy them into your production environment.
The customer that I think you're talking about also, or any of them, they were not on they were not on the latest cores, and the reason they weren't moving to a newer version of that particular software is because it was incompatible with their code. And this is something we see a lot where updating the infrastructure requires updating the code, and companies, make that decision that it's too expensive to update their code for a new update. There will be too much downtime or something like that. But it makes the situation worse because getting fixes for CVEs is usually going to be provided at latest versions or close to latest versions. Something to look for here is just LTS, which is long-term support. So you always want to make sure any software you adopt has an LTS, a long-term support channel. Um, and if things are going end of life, take that seriously.
Yeah, I can attest to that. I mean, in a previous life, I worked very closely with the Spring framework, and I remember a point in time where a big version jump happened, and all of a sudden, all the customers were like, "Whoa, hold on, we gotta go refactor code, we gotta figure all this stuff out." Which I think is a great transition into one more question for either of you to say, like, what is the state of sort of open source security and maybe more specifically container security look like for the customers you're talking to today? Like, are people actually thinking of this? Are people prioritizing this in their organizations? And I think going to what you just talked about, Mark, like, are people willing to go and do this work like code refactoring that maybe doesn't move the needle forward in terms of functionality, but is critical to your own security posture? Like, what does the state of that look like in the world right now for you?
It feels like rarely, if ever, customers are actively like looking to do that internal work, but I feel like most of the pressure is coming from outside. Like they need to be FIPS compliant, or they need to be FedRAMP compliant, or they need, their internal security team has adopted a posture to say zero CVEs. So, they're scrambling to come up to this compliance bar. But I feel like in most of the cases we've seen, it's usually coming from outside of the development team to say these are these are, is that you see that, Norris? You feel
Yeah,
that?
I can actually take this a step further. So FIPS and so when we talk about CV remediation at the time that the SLA for those FedRAMP is kind of leading the charge here. And I think it's something that the entire industry should align to. I recall a recent deployment with a customer, and you were involved in that, Mark, as well, where they came to us and said, our policy or the board has mandated that we need to remediate at least 65% of the open vulnerabilities we have. And they estimated that to take roughly a year to fully implement. Again, a lot of companies miss kind of quantify how long it will take because they did use Wiz, and the report was a little bit scary. But when we really we really understood the S bombs, and we understood that a lot of those components have been basically duplicated within those environments. You don't really have to fix everything. Just the same component can be fixed and then deployed multiple times. So we were able to get them from a 65% to a 99% in a matter of a couple of weeks, just because most of the components were very similar across their images. And this is where an SBOM can make our lives a lot easier. Just understanding what is the blueprint of everything that you have. Because Wiz or Snake, all those other tools will give you a really scary dashboard, as it should. But it's really to understand which components are you running. A lot of those components we actually eliminated because they didn't really even need them in the environment. So many of those CVEs that were OS based, once you move to a distroless environment, were basically eliminated. So it didn't have a much impact on the application layer, just the OS level. So always recommend follow best practices, use SBOMs, and really understand what you have in your environment before you start remediating everything.
Awesome. So there is 5 minutes left. We said we would get to some questions, so I want to make sure we do that. The first one, I think selfishly I'm interested in as well, and it's sort of, I think this would be a great question for Mark. Like we sort of touched on this at a high level earlier on in the session. It's a very deep topic, of course, but if an organization wants to start securing their containers today, like what is the first practical step you would take? Is there a sort of checklist you could apply to work through a problem like this?
Oh, yeah. So really the first thing if you're interested in doing hardened containers in your own org, check if your business has their own hardened container base, right? Um, like if someone's already done all of this work for you, use that. The second thing, and it goes to some of the panel questions, is you really need to know we say like your top level requirements. What is the application that you need to run on your system? And you need to collect that information. You need to basically diagram out, I need, HA proxy, and HA proxy uses this library, and we can build this C library. And there's the library and there are some executables. Knowing that you don't need these executables, you just need the library for this application to rest on. So really, if you have a good picture of the top level application and exactly what dependencies and which parts of those dependencies you need to run everything, then you can start putting that container together with a sense of minimalization and without breaking functionality because you know exactly what you need. Yeah. Let's see. Do you want me to keep going on, like checking things off?
No, you know what? I think that's a great kind of introduction. And, I'll talk about it in a minute, but we have another session sort of lined up to go even deeper into this, which I'll talk about. But I want to make sure we get to a couple other questions. If you do have a question, I think please mention it in the questions tab. If we don't get to it today, we will make sure to follow up with you. But, one other question I think that might be worth hitting really quick is just like, are there any tools out there that either of you would recommend to sort of help with this process, whether that's sort of, looking at the size of an image or any sort of minimization techniques? Is there anything there you would recommend?
We use a tool called Dive a lot to look inside containers that don't have a file system because they've been ripped out. So being able to have that, so Dive is what we would recommend for that. And then we use Gripe a lot for CVE scanning because it seems to be one of the better open vulnerability scanners, and it gives really good feedback.
Awesome. So we are coming up on time. So apologies if we had a shorter question session today. Please reach out to us if you do have any questions or just want to chat about anything we talked about today. The team, I think, would be more than happy to chat with anyone about container security or any related kind of challenges you may be facing. And I also just want to call out that we do have one final session in the series lined up for Tuesday, November 25th at 8 a.m. PST or 11 a.m. EST. So I do hope to see everyone there. And that's going to focus again on sort of building out your own blueprint to focus on container security. So, Mark started getting into it, but really breaking that down a step further and giving everyone sort of a tangible framework to do this themselves. So we will send out the recording for today's session. Thank you very much, everyone, for joining. Mark, Morris, thank you for joining me today. And I look forward to seeing everyone in our next session.
Thank you.
Thank
Have a
you.
good day.
Awesome. Thank you very much, everyone.
Bye.